trigonometric equations. In this lesson, we're going to talk about how to solve trigonometric equations 3 different ways. First, by using a graph, a given graph. Second, by using technology, also known as using a calculator. And third, so we'll spend the most time on, how to solve it using algebra. So let's talk about that first way first, given a graph. So graphical solutions of a trigonometric equation. If we are given a graph with sufficient accuracy, we can use it to estimate solutions. So here's our example. Solve cosine of x is equal to 0.4 for x is between 0 and 10 radians using the graph of y equals cosine x. So here's a graph of y equals cosine x. It wants to solve where cosine x equals 0.4. So general key with this is 0.4 is our y value. Right, so like this is like your y1 and your y2, and when you graph, you want them to see where they cross. So all you gotta do is figure out where it's 0.4 on your graph on the y value. So here's our y. Go to 0.4, which should be about here, if they're kind of by ones, and go all the way across. And that's all we're gonna do. If you notice, right, they only want it between 0 and 10, so from 0 to 10 is all we're going to count here. And all I got to figure out is where do they cross. Well, they cross right here. I can estimate that to be like, it looks like 1.3, I'm going to say. They cross right here. It looks like 5.1. I'm going to estimate 5.1. And they cross right here, which looks like 7.4-ish. And that's how you figure out where two things cross given a graph. Let's look at the next one. So we're going to do A first. Same idea, but now with the tan graph. And the reason I want to do this one is because look at the domains are different here. One of them goes from 0 to 8, and one goes from 0 to 2. We'll do this one first. So here's our tan graph. It wants to solve tan of x equals 2 from 0 to 8. So same idea. This is like my y1, my y2. Y1's already graphed for us. We have to figure out where y2 is, what the graph of y2, y equals 2 is. So here's 2 on my y. We just go straight across. Around there. A little off, but that's the general idea. And then I want all the solutions. So they cross from 0 to 8, which is right there. So they cross right there, and right there. We can estimate them. I'm not actually going to go through the trouble of it, but you can look there. Estimates like 1.6 and 4.5, yada yada. Now look at C. They want to do the same thing, but in this case, they only want us to go to 2 pi. Now we could assume pi is like about 3.14. So 2 pi would be 2 times that, which would be 6.28. So we actually only want to go to about 6.28 to around here. That's it. So our graph's going to go from here to about there. I'm not going to look at anything past that. Very important because it changes your answers. So same idea. Y1, y2. Where does y equal 3.5? About right here. This one goes straight across. But again, I'm going to stop around there, because that's all 2 pi hits. So I'm not going to include this one right there. So it'll be these two values. So it looks like, I don't know, 1.7 and 4.9. Just estimating. And those are your answers. So keep in mind, right, all you're doing is graphing the two things. So luckily first, tan's already graphed for us. And then we just graph y equals 3.5 and see where they cross. In this case, within the domain, keep in mind of the domain, they only cross 2 times. And I can actually find them. I can estimate them. So that's how you solve by graphing. Next, let's talk about how to solve using technology, using the calculator. Well, it's actually a very similar method. You just got to graph it yourself on the calculator. So we're going to use this left side as y1 and our right side as y2. Then you're going to bring out your calculator and you're going to type them in. So I'm going to turn it on, go to y equals. I already spent the time to plug them in. So there's y1, there's y2. Now a couple things it does mention here. If you're trying to solve this, look at your domain. Notice how it's in radians. So you want to make sure you're in radian mode. So you're just going to hit mode. And we are in radian mode. So get out of that. next, after I graph it, you can see a graph happen here. I'm gonna have to fix my window. So the default by most calculators is negative 10, 10 on your x, and then negative 10, 10 on your y. But look at my values here. My x is showing to go between 0 and 2 pi. So we're just gonna type that into our window. So you go to window, make it 0 and 2 pi. Now, for your y's, you generally want to look at the domain. You want to look at your min and max. Look at my sign here. If you remember from a couple lessons ago, the max of that sine function is the amp, which is 2. And then a cosine part goes up to 1. So you want to be around, like, you don't have to go any past like 3 or 4 just to be safe. I'm going to go like negative 4 to 4 just to get a nice window. Like I don't have to go away to negative 10 and 10. You just want to go around your max, a little bit past your max so you can see a little nicer. So I think my max is about 2 or 1. I'm going to go 4 just to give it a little buffer. Then I'm going to hit graph. And you can see again to only graph from 0 to 2 pi. When you hit 2 pi, it changes it to whatever the math version is. And then here's our 3 solutions from 0 to 2 pi. If they want us to find all of them, we just have to figure out the intersections. Now the thing you don't want to do is just hit trace. Oh, I hate when people just hit trace and they try to like trace it. That's like an estimation. You want to get the actual values. You want to go second, calculator, and hit intersect, so number 5. And all you gotta do is move that little thing to get close to one of them. Sometimes if you press up and down, it switches between them. And sometimes the other one's a little faster. At least appears a little faster. So get close to it, then just hit enter a couple of times. Is that the second curve? Yes, it is. Do you want me to guess? Yes, I do. And you get the intersection of 1.816213, or an IB 3 sig figs 1.82. We're going to do the same for all of these, so I'll just do another one real quick. Second, calculator, intersect. I'm going to press down because I think that one's a little faster. And I'm just going to move closer to that one. Again, once you get close, hit enter for the first curve, then it'll say, is that the second curve? You hit yes, and then guess, and yes. And 3 sig figs, that'll be 3.28. And then the final one over there, same idea. The second calculator intersect. This one, to get close to it, it'll be right on it. See, that's how it takes. It feels like it takes longer. If I would have pressed up, I'll be on this one. It feels like it go a little closer. And when you don't get that close, you just gotta get somewhat close. Hit enter, and then see how it jumps to the other curve. It says that your second curve, and you say yes, and then guess, and we get 5.81 3 sig figs. And those are my answers. So that's how you solve on the calculator. You do y1, you do y2, you graph it, you fix your window so you can see where it crosses, then you find intersections. Now let's get to the main part of today. Solving using algebra. So, when we solve these, we always want to isolate the trig function. So we're going to isolate the trig function. Then generally we're going to do all students take calculus to figure out the correct quadrant. So that's this, all students take calculus to figure out what quadrant we're in. Next, we do SOHCAHTOA, which are given to figure out the sides. And that should tell us what type of triangle it is. And then 4, we figure out the angle. So let's put that in practice with this first one here. So first step, it's already solved. It's already isolated for cosine. So next I'm going to do is all students take calculus. From before, we know that this means that all trig functions are positive in the first quadrant. Only sine is positive in the second quadrant. Only tan is positive in the third, and only cosine is positive in the fourth. Now, so for a cosine, the sine chart would look like this: plus at A and plus at C. They're always positive. Cosine, all trig functions are positive at A, and only cosine is positive at C. My value is actually negative, so I need the negative values, which are these two quadrants. So that's the quadrants we're going to be in. We're going to be in quadrant 2 and then quadrant 3. And our whole goal is to figure out what angle that is right there. Now, I know that based on SOHCAHTOA, I know cosine is adjacent of hypotenuse. So that means that this is going to be A and that's going to be H. So my adjacent is going to be negative √3. And my hypotenuse is going to be 2. So I have a triangle with negative rad 3 on the side and 2 in the hypotenuse. That should right there let me know that the missing side is 1, which makes this a 30-degree triangle. So for reducing degrees, right, this would be 180. When you do angles, you always go from right here, so where you start is 0 degrees, and I can get all the way to this hypotenuse. Well, if this is 0 and this is 180, this is 30 less. So this would be 150. And then this is 0 and 180. We want to get to this line also. Well, that'd be 30 more than 180, or 210. So 150 and 210. That's how you do it in degrees. In radians, it's a very similar idea, but instead you gotta memorize your radians. So if you recall from before, pi over 3 is 60, pi over 4 is 45, and pi over 6 is 30. Since I have 30 right here, I know this is a pi over 6. So the trick is, since this is 0 and pi, right? When you do radians, it's 0 and pi right there and 2 pi. I'm going to make this a 6 over 6. And then this right here would be 1 less. You haven't reached it yet. So this would be a 5 pi over 6. And this would be one more. You got a little past it. So 7 pi over 6. So 5 pi over 6 and 7 pi over 6 are my answers in radians. Just for time, we're going to skip this one. We'll do this one right here. Similar idea. So I want to isolate tan. So I'm going to get tan of x equals negative rad 3. Just subtract rad 3 from both sides. And that's all I can pretty much do. Tan is isolated now. I have a negative value, so I'm going to do the same concept. I'm going to do all students take calculus. Again, we have a negative value. Tan is positive at a and at t, because everything's positive a and only tan is positive t, so it must be negative here and here. My value is negative, so my quadrant is going to be quadrant 2 and quadrant 4. Well, by the way, I didn't talk about, we're going from 0 to 2 pi, my domain. So this is all your answers. This is one value. We'll do ones later on where you go a little past it. But for now, these are all my answers going to be at. For tan is TOA. So opposite over adjacent. I'll put it over 1 there. So I have opposite over adjacent. So my opposite is rad 3. And my adjacent's 1. Sign doesn't really matter because we already know the quadrants are in. So rad 3. I know rad 3 is always opposite to 60. Rad 3 is the biggest one. So they're your 60s. Now I'm just do radians here. So if I do this in radians, rad 3, 60 degrees is rad 3, pi over 3. So I'm doing the exact same trick. Here's 0. Here's pi. If I want to get to this right here, since I know 60 is pi over 3, I'm going to make this 3 over 3. This would be 1 less. We haven't reached 3 over 3 yet. So this is 2 pi over 3. And down here, so this is 3 over 3. I get 4 over 3 right here, but I got to get all the way over there. So you just got to go 3 over 3 plus another 3 over 3, which makes this 6 pi over 3. And 1 less would be 5 pi over 3. Right, so 2 pi over 3, 5 pi over 3. So you go 3 over 3, 6 over 3, then you're a little less. So those are my 2 answers there. Let's do a couple more. This one with the square. How does that change things? Well, you do the same way. Got to isolate this, so I got to square root it. So I'm going to get cosine of x equals square root of 1 over square root of 2. When you square root something, you get plus and minus. So plus and minus 1 over radical 2. That's as far as I could go. So now we're going to do the same thing we always do. Draw my little thing here. 0 and pi, 2 pi. All students take calculus. Now in this case, it's plus and minus. So that means every single quadrant works. The positive and the negatives. So everybody gets a triangle. Right, because it's plus and minus. So plus cosine is positive A and C, and it's negative at S and T. Now it's 1 over rad 2, so I already know what type of triangle this is. Anytime you see rad 2 should be a dead giveaway, it's going to be 45. It's a 45, 45, 90 triangle. So these are all 45 degrees. And if you remember from up there, 45 degrees is pi over 4. So those would be my answers. This right here, quadrant 1's always just a basic one over the number, so pi over 4. There's no special frills to it. Pi over 4, pi over 3, pi over 6, all in quadrant 1. So pi over 4 in this case. Use my trig here. Pi, so 4 over 4. This will be 1 less, so 3 pi over 4. This will be 1 more, so 5 pi over 4. Right, so this is 4 over 4. I got to go around again, so you set another 4 over 4. So it's 4 over 4 this way, plus another 4 over 4. Will get me 8 pi over 4. 1 less will get me 7 pi over 4. And those are the 4 answers between 0 and 2 pi. Again, 2 pi is unlimited because right there, you hit 2 pi. Now for the next one, the domain actually changes. It'll go from 0 to 3 pi. But I decided we're going to do so. We'll spend a whole new video on this, how to do stuff like that, because it gets a little complicated. So instead, we're just going to pretend these are all, let's say, 0 to 2 pi. So we can focus on that. So we can focus on that today. I'll come back in this video. We'll come back and do that in a later video. So this is the basic one. Let's start with this one. See how it's not just a basic sign? It's sine of 2x. So obviously there's something inside that parenthesis. Well, what you do is you ignore it. Ignore it till the end. A lot of people call this u substitution. So you just pick another variable, you put it there for the 2x, and you just solve it like that. To me that complicates a little too much, but it's the same idea. And I just noticed it's another negative problem. Let's just switch that. We've done a lot of those. Let's do a positive problem for once. So let's make it positive 1/2, just a little change of pace. And we're going to go a little faster on this one. So here's all students take calculus. Since we are doing sine, it's positive a because they all are, and it's positive s because it's sine. So again, remember, I made a positive 1/2. So my quadrants are up here. Now 1/2, SOHCAHTOA for sine, so O over h. So opposite's 1, hypotenuse is 2. And that right away tells me it's a 30-degree angle, because 30, 60, 90 triangle, 30 is the smallest one, so it gets the 1. Now remember, in radians, 30 degrees is pi over 6. So this will be 0. And this will be pi. Or using my trick, this will be 6 over 6, which makes this guy 1 less. 5 pi over 6. Anytime you're studying quadrant 1, it's always just the 1 pi over whatever you're talking about. In this case, 6. So those are my answers. Pi over 6. I guess technically it should be u. And 5 pi over 6. So that's like normal. So what does this 2x comes in? Well, the thing you found wasn't for 2x. Well, sorry. The thing you found wasn't x. It was 2x. So it's actually 2x equals pi over 6 and 5 pi over 6. So I mean by you ignore it to the end. You solve like normal. At the end, you come back and you just put, okay, it's a 2x I've solved it for. And all I do here is solve for x. So let's multiply both sides by 1/2. Bad math grammar, but I'll be fine with it. So 1/2 times pi over 6 is pi over 12. And 5 over 6 times 1/2 is 5 pi over 12. So I have that. Now, that might not be all the answers between 0 and 2 pi, but for now I just want to focus on how to solve it. We'll come back to talk about how to fill out all the values later on in a later video. So right now I just want to focus on how to solve trig functions. And that'll be the idea. And it'll be the same thing for the next problem. Right? So sine of x minus pi over 6 equals 1/2. I did the same problem. The difference here is, instead of being a 2x inside, it's an x minus pi over 6. Well, you do it the same way. You would solve where does sine equal 1/2 at. We actually already did it. We know it's pi over 6 and 5 pi over 6. So what happens here is, remember, you did not solve for x. You solved for all of this guy. So you just put that back at the end. X minus pi over 6 equals pi over 6, this guy. And x minus pi over 6 equals 5 pi over 6, this guy. Then you just solve each one separately. In this case, I would add pi over 6 on both sides. And I would get 2 pi over 6, also known as pi over 3. On this side, I want to add pi over 6 on both sides. I would get 6 over 6. or just known as pi. And those would be my answers. Now again, a lot of times I'll have to check to make sure it fits a domain, or if there's a lot more that fit in the domain. But for now, I just want to focus on how do we actually solve this stuff. And that's how you would do it. The next one is a tricky one. So you have rad3 sine x equals cosine x. Now, a lot of times, if you could use a calculator, it's easy. Just graph y1, y2. In this case, if you want to do it with using algebra, you got to know the trick. And what I do is I think tan equals sine over cosine. So that's what I want to get. I want sine over cosine. So what I'm going to do here is I'm going to divide both of these sides by cosine. Equals 1. So I divide both sides by cosine, then I get sine of x over cosine x, which is tan x. And I get rad3 tan x equals 1, or tan x equals 1 over rad3. So that's the trick I use. So when I see sine equals cosine, I try to remember, okay, tan equals sine over cosine. So I try to force that to happen. So divide both sides by cosine in this case. The one thing you remember that you can't divide by 0, so you can't. So cosine in this case cannot equal. When does cosine equal 0? Pi over 2 or 3 pi over 2. So you can't get those answers. If you get those answers, it's a bad solution. But other than that, you should be fine. So then how do I solve this? You solve this like normal. When does tan equal 1 over rad3? Let's do this really quickly. All students take calculus. Tan is positive at a and at t. So my quadrants are there and there. Tan is TOA. So opposite over adjacent. So opposite's 1, adjacent's rad3. That's again a 30-degree triangle. So this would be 30 is pi over 6. This would be pi or 6 over 6. And this would be 1 more 7 pi over 6. So those will be my answers. Pi over 6 and 7 pi over 6. So again, that's a tricky one. The next one. If you notice, it goes all the way. First, it's like kind of messy, but it goes all the way to 6 pi. Again, we're not going to deal with that today. We'll do that on the next video. So let's pretend it's 2 pi. Well, I just want to focus on to solve it. So, notice how there's something on the inside. We're just going to ignore that for now. Ignore to the end. So, we just want to isolate that cosine. So, we're going to subtract 1 and divide by rad2. So, we look like this. Rad2 cosine. We'll do a little u sub so it actually looks easier. Equals -1. And then divide by rad2. Alright, the u just means that I'm going to ignore that to the end. I'll deal with it later. So I get cosine of u equals -1 over rad2. Remember what I said earlier? If you see a rad2, dead giveaway, it's 45 degrees. So, all students take calculus. I can figure out what cosine's negative. Well, it's positive at a and c. So it must be negative at these two. Those are my quadrants go. It's a bad right triangle. So TOA, a over h, 1 rad2. Like if I see rad2, I already know automatically it's 45. So 45 degrees equals pi over 4. So 0, pi, use my trick, 4 over 4. So 1 less, 3 pi over 4. 1 more, 5 pi over 4, sorry. So those will be my answers for now. Right, but what can you not forget? Let's go back to this thing I ignored. Now I got to put that back in. So it's actually two problems. X minus 3 pi over 4 equals 3 pi over 4. And x minus 3 pi over 4 equals 5 pi over 4. And I just got to solve this basic problem and then we're done. Add 3 pi over 4 to both sides. And I get x equals 6 pi over 4, also known as 3 pi over 2. Add 3 pi over 4 to both sides. And you get x equals 8 pi over 4, also known as 2 pi. Which would be my max, since I changed it. And that's the idea there. Let's move on to the next one. So this one's a little different. Find the unknowns in each function. When we talk about modeling, when we did this, we try to find the middle by having the max and min, or we try to find the amp. This case, I don't have that information. All you have is this equation and you have 2 points. You have this point, where it's fairly obvious, and you have this point a little less obvious. That's a y-intercept, so it's a point 0, 2. So now you have 2 points in the equation with 2 rows you're looking for. So let's sub some equations. We're going to sub this into there and see what happens. Now when you sub it in, that's x and y. So y would be 7/2 equals 3 sine of b to the pi over 2 plus d. And then we also sub that one in. So we're going to have 2 equals 3 sine of b times 0 plus d. And this is the one that's the key, right? So 0 times anything is 0. So I'm going to get, if I simplify this one a little bit, I'm going to get 2 equals 3 sine of 0 plus d. Now you got to figure out what sine of 0 is. That's the unit circle. Here is 0. So that's the 0.10. Sine e, sine's the y value. So this is all just going to be 0. So I get 2 equals 3 times 0 plus d, or just 2 equals d. So that's what 2 equals. And once you find one variable, you just plug into the equation. So in that equation, I now have 7/2 equals 3 sine of b times pi over 2 plus 2. So let's just isolate this thing. I'm going to subtract 2, divide by 3. So that's common denominator. That's going to be 4 over 2. So I'm going to get 3 over 2 equals 3 sine of b times pi over 2. Right, so this 7/2 minus 2, or 4 over 2, so you get 3 over 2. Now let's get rid of that 3 there. So multiply by 1/3 both sides. Those cancel out, and you get 1/2 equals sine of pi over 2b. Remember the way we solve this? You just ignore this till the end and just figure out where does sine equal 1/2 at. Up here, all students take calculus. So I get 1/2. That is a 30-degree triangle, so you get it at pi over 6 and at 5 pi over 6. Now if you notice my graph, it looks like it's the very first time we hit it. So what is it going to do with the pi over 6? So that means x equals pi over 6, but don't forget, we actually didn't solve for x, we solved for pi over 2b. So we got to plug that back in and solve for b. So pi over 2b equals pi over 6. Let's get rid of this pi over 2, so times by 2 over pi, times by 2 over pi. These cancel, and over here, these reduce, and these cancel, and I get b equals 1/3. So my answers are b is 1/3, and d is 2. Right, so that's what we're going to do. These is 2 equations to unknowns essentially. Plug it in, simplify. Okay, one last part into the most advanced of the solving. So how do we solve when we have equations like these guys? Multiple sines, multiple cosines. Well, the trick here is just to factor. So it's going to be the same idea. We have squares here. We solve all square problems, quadratics the same way. You want to set equal to 0. You want to factor. You want to split and solve. So just like we're in Algebra 2 class, same concepts. So look at the first one here. I have 2 sine squared x plus sine of x. Sometimes I've noticed it helps people if you just ignore the signs. Pretend it's 2x squared plus x equals 0. So just ignore the signs for now. How would I solve that? Well, they both have an x. So we could factor out an x. And you get this. And once you factor, you can plug your signs back in if it helps. Sine of x, 2 sine of x plus 1 equals 0. Now we're just going to split this. Sine of use the 0 property. Sine of x equals 0. 2 sine of x plus 1 equals 0. Then we solve each one separately. Sine of x equals 0. That is a unit circle. Anytime it's 0 or 1, it's one of the unit circle values. So this is 0. This is pi over 2, 3 pi over 2. This is 1, 0, 0, 1, negative 1, 0, 0, negative 1. We're doing sine e. so it's the y value. So it's here and here, 0 and pi. 2 sine of x plus 1, we just got to solve it, get the sign by itself. So 2 sine of x equals -1, sine of x equals -1/2. Probably done this from like 7 times in this video. All students say calculus, it is negative, so it should be down here, because sine is positive on top, a and s, but we want the negatives. It's -1/2, so opposites -1, SOHCAHTOA, and adjacent hypotenuse 2. If you don't know by now, that's a 30-degree triangle. And we should know 30 degrees is pi over 6. So using my trick, this is pi or 6 over 6, which makes this a little bit past it. 7 pi over 6. And this one right here, now you can't get there yet, but if this is 6 over 6, if you went around again, you get 12 pi over 6. So this will be one less, 11 pi over 6. And that's the idea, and you get 4 answers from that. If I was going to do this one, it's the exact same idea, just the factoring's a little worse, but it's the same concept. 2 cosine, let's ignore the cosines for now. 2x squared plus x minus 1 equals 0. Don't need this anymore. Right, so it's the same idea, but its factors a little worse. You multiply those together, you get -2x squared. Find the combo that gets you 1. That'll be 2x and -1x. Sub it in for the middle. 2x squared plus 2x minus 1x minus 1 equals 0. Factor by grouping. Or however you like to factor these. Pull out the, I always bring in the middle sign, so that when you factor them, you're dividing, so it becomes x plus 1. -1 divided by -1 is plus 1. These match. You're left with this. And don't forget to plug your cosine back in. So cosine of x plus 1. And 2 cosine of x minus 1 equals 0. Split and then solve each one separately. One half. So to solve those, same idea. Where does cosine equal -1 at? That would be the x value. So at pi, where does cosine equal 1/2? Here and here. 1, 2. Let's make this rad 3. If you know by now, that's going to be pi over 3. 3 over 3. 6 pi over 3. So I would get pi over 3 and then 1 less from there. So 5 pi over 3. And that would be my answers. There we go.